Welcome back. We're going to be talking about section 4.2 again. We're talking about the domain of sine and the cosine functions. So for the domain of sine and for cosine, for sine, you can see our x-coordinates. We're going from -1 to 1. So our domain for sine is between -1 and 1 with brackets. For cosine, same thing. Our domain goes from -1 to +1. And our range for sine, our y-coordinates. It's going from -1 to +1 for sine. And our range for cosine is also from -1 to 1. So the domain and range for sine and cosine are both from -1 to +1. Now, sine and cosine are periodic functions. Now, they're periodic functions, so what happens is that it's just going to keep repeating itself as you keep going around the circle. So what I mean is if we have pi over 2. Now, pi over 2 is going to land on the unit circle right here. Now, if we add 2 pi to that, so we're starting here, and we go around another full circle, we're going to end up back at the same place. So pi over 2 plus 2 pi, or 5 pi over 2, that's going to be the same location as pi over 2. And we can add another pi over 2, or sorry, 2 pi, and that would bring us to 9 pi over 2. That's going to be in the same location. We could just keep adding 2 pi, and it's going to bring us back all the way around the circle. By adding 2 pi, it's going to bring us back to our same spot. So pi over 2, or pi over 2 plus 2 pi, or pi over 2 plus 4 pi, they're all going to be the same location. So here we'd have 0, same location as 2 pi, same location as 4 pi, for example. Or if we add pi over 4, it's the same location as pi over 4 plus 2 pi and pi over 4 plus 4 pi. And that's going to work with all of these. You're just going to, if you add 2 pi, you're going to end up back at the same location. So if we're looking at evaluating sine and cosine for 13 pi over 6, now that's already above 2 pi. So what I can do is I can find its basic angle. So it's the same as the sine of, now 13 pi over 6. That's the same as 12 pi over 6 plus pi over 6. So what that is that's 2 pi plus pi over 6. So really all we care about is the pi over 6. Now we know that whenever we have a pi over 6, we're going to be at root 3 over 2, 1/2. We're in quadrant 1, so they're both going to be positive. So we can find the sine of 13 pi over 6 is that y-coordinate is just going to be 1/2, the same as the sine of pi over 6. And that's all we're doing. So we're just going back to the original angle without the extra circles added into it. For a -7 pi over 2. Negative just means we're going clockwise. Now, 7/2, that's the same as -7 pi over 2 plus 8 pi over 2. So that's the same as pi over 2. Because if we go back, 7 pi over 2, there's pi, 2 pi, 3 pi, 4 pi, 5 pi. Ignore that, I forgot my over 2's. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. You can see that's the same as pi over 2. And whenever we have a pi over 2, it's going to be, well, not, excuse me, it's going to be at 0, 1 for this one. There's our coordinates. So for the cosine of negative 7 pi over 2 is going to equal the same as the cosine of positive pi over 2. That's going to be our x-coordinate, which is 0. And that's how we can use that. So let's go to the next page, please. Talking about even and odd functions. We talked about an even function and odd functions in previous chapters. As a review, a function is even if f of negative t equals the same as f of t. That when you evaluate at the negative, it's the same as when you evaluate at the positive. They have y-axis symmetry. And we'll see that when we graph these. A function is odd if f of negative t is the same as negative 1 times f of t. And that has origin symmetry. The only two functions that are even are cosine and its reciprocal secant. So if we look at this, the cosine of pi over 6. Now, whenever we have a pi over 6, it's going to be root 3 over 2 and 1/2. So for a pi over 6, we're in quadrant 1. So the cosine is the x, it's root 3 over 2. Now the cosine of negative pi over 6. Now, just going to make a little sketch. Negative pi over 6, this means we're going clockwise. So that tells us we're in quadrant 4. So it's negative root 3 over 2. Positive root 3 over 2. Negative 1/2, because in quadrant 4, it's positive negative. And the cosine of negative pi over 6 is root 3 over 2. You see how they're the same values? That's showing us that they're even. And you could do the same thing with secant, because remember, secant is just the reciprocal. Reciprocal doesn't change the sign. Now, all the other ones are odd. So we're looking for the sine of pi over 6. Remember, for our pi over 6, we're going to be at root 3 over 2, 1/2. So the sine of pi over 6 equals the y, 1/2. The sine of negative pi over 6, once again, remember, we're just going backwards. We're going to be in quadrant 4, so it's going to be root 3 over 2, negative 1/2 this time. And you can see the sine of negative pi over 6 is that y-coordinate, the negative 1/2. You see how they're opposites of each other? That's what makes it an odd function. And you could do it with the other ones as well. Now, when you evaluate the trig functions with a calculator, make sure you're in the correct mode. Make sure you go to mode. If your answer isn't, if your question's with degrees, make sure you're in degrees. If you have radians, or if you see pi radians or pi, you want to be in radians. And it's going to be important to be in the correct mode for what you're trying to do. Now, your calculator does not have a cosecant button. So if you're looking for cosecant of theta, you have to do 1 over the sine of theta. If you're doing secant of theta, it's 1 over the cosine of theta. If you're doing tangent of theta, cotangent of theta, it's 1 over the tangent of theta. You have to divide 1 by whatever you're looking for. So for all of these problems, 2 pi over 3, 1.5 and pi over 8, you want to be in radians. So make sure your mode is in radians first. So what we're going to do is we're going to do the sine of 2 pi over 6. And your calculators have a pi button. Use that. So when you do sine of 2 pi divided by 3, make sure you use parentheses. You're going to get 0.8660. There's our value as a decimal. The cotangent of 1.5, you're still in radians. It's 1 divided by the tangent of 1.5. And when you do that, you're going to get 0.0709. And for number 14, the cosecant of pi over 8, you're going to do 1 divided by the sine of pi over 8. And make sure you use your pi button. So when you do that, you're going to get 2.6131. Okay, and that is the rest of section 4.2. Working with that unit circle, we're going to have some easier times and some more difficult times. It's all about knowing where the values are on that unit circle. Okay, thank you for your time. I will see you in the next video.